Problem 49 reads, which of the following describes the total number of dots in the first n rows of the triangular arrangement below? So to solve this, notice that the first row is indicated here, which means that it's this one with 2 dots. The second row is this one with a total of 4 dots. The third one is this one with a total of 6 dots. The fourth one, this one, with 2, 4, 6, 8. And then the last one is this one with 10. A common mistake would be to not realize that it's really the first row right here, the second, the third, the fourth, the fifth, etc. Now, they want us to find or pick the choice that describes the total number of dots in the first n rows. In other words, if it's for row 1, then n should be equal to 1. If we're trying to figure out how many dots in row 2, then n would be equal to 2, etc. So choice A is obviously nonsense. 30 would mean that every row would have 30 dots. So you would have something like 30, 30, 30, etc. And that's clearly not what we have. For B, 2 times n, well, let's try it out. The first row has, because n is equal to 1, if we were to replace the n in 2n with 1, we get 2 times 1, which is equal to 2 dots. It works out. We can't claim victory, though. We have to keep checking. For the second row, n is equal to 2. Plug it in. 2 times 2. We should have 4 dots. Yes, we do. For n equals 3, we plug in the value of 3 for n. 2 times 3. 6 dots. At this point, you should realize that it is going to work out because you always have starting with 2 and then just adding 2 units or 2 more dots as you increase the row number. And that's exactly what this formula is providing. So choice B is correct. C is wrong because n squared with n equals 1, you get 1 squared, which is 1 dot for the first row. That's incorrect. N times n plus 1 is not going to work either because, say, for the third row where n equals 3, you would have 3 times 3 plus 1. So that would be 3 times 4, which is 12, not the number of dots you have for the third row. You have to be careful with these that you don't test just the first row, because n is equal to 1 and that number has, some very interesting properties. You may end up picking the wrong answer if you only test it with the first row, with n equals 1, in other words. And that applies to most of the equations that accept values if you only use n equals 1 or n equals 0 or n equals -1 or x or whatever variable is being used. 0, 1, -1, those numbers often have some very interesting properties when you're using them in equations. So remember to check for multiple values and make sure that it does work out. Anyways, D doesn't work, and E obviously is not going to work out. It's going to end up giving you too many dots. Problem 50 reads, after polling a class of 24 students by a show of hands, you find that 9 students play soccer and 21 students play basketball. Given that information, what is the number of students in the class who must play both soccer and basketball? So let's analyze this carefully. You have a class with 24 students. You ask, who plays basketball? And 9 students raise their hand. With soccer. Then you ask, who plays basketball? And 21 students raise their hand. Well, since there's only 24 students and yet a total of 21 plus 9, 30 students raise their hand when asked which sport they play. Clearly, if we subtract 30 minus 24, we get 6. 6 students had to raise their hand for both sports. A way to look at this as well would be with a Venn diagram. So if we use this circle and put the students that play soccer inside that, and then another circle for the students that play basketball, well, since 6 students play both sports, that would be in the intersection of both circles right here. These students play both soccer and basketball. Now, if a total of 9 students play soccer, then 9 minus 6 is 3. That means that 3 students play soccer exclusively. And if 21 students play basketball, well, 21 minus 6, which is 15, 15 students play basketball exclusively. Let's add these numbers now. 3 plus 6 is 9, and then plus 15, you get 24. exactly the right number of students. So therefore, choice J is correct. Now this Venn diagram, although not necessarily needed for this prompt, it could help you if the question had been posed differently. Problem 50 talks about polling 24 students. 21 play basketball and 9 play soccer. So if you do 9 plus 21, you get 30. So a total of 30 students would play both sports. However, there's only 24 students in the class. So if you do 30 minus 24, that means that 6 students would have to play both basketball and soccer, which is choice J. For problem 51, which of the following is a set of all real numbers x such that x plus 2 is greater than x plus 5? Well, just think about it. On the left-hand side, we have this expression, x plus 2. And we need this to be greater than x plus 5. Now, we're allowed to use the real number system exclusively. So this means whole numbers, natural, of course, whole numbers, integers, rationals, and irrational numbers. Now, if we're constrained to just those numbers, look at this expression. How can the left side ever be greater or bigger than the right side if they both contain an x? So these elements will always be the same. So, if we put an x on a weight scale, this type of a scale balance, if we put an x and an x, clearly it's going to stay balanced, right? Now, what happens when you add 2 to the left side? Well, you're adding more weight to the right side than to the left side than to the right side. But then look at the full expression on the right side. You're actually adding more. You're adding 5. So can this ever happen? Can x plus 2 ever be greater than x plus 5? Not if we're using the real number system. So the set containing only 0 doesn't work. You can try the number 0 and plug it in. 0 plus 2 is 2. 0 plus 5 is 5. 2 is not greater than 5. The set containing all non-negative real numbers. False. Plug in any positive value. Say 1. 1 plus 2 is 3. 1 plus 5 is 6. 3 is not greater than 6. Or 10. 10 plus 2 is 12. 12 is not greater than 10 plus 5, 15. This is never going to work. Then with C, the set containing all negative real numbers, well, say negative 20. Negative 20 plus 2 is negative 18. So you're thinking, hey, maybe this will work. But look what happens here. Negative 20 plus 5 is negative 15. And negative 18 is not greater than negative 15. Be careful. So C doesn't work. D, the set containing all real numbers, well, of course not. We've already excluded a bunch of them, which leaves E, the empty set. The empty set means that there's no solution. The empty set means there's no value for x that we can plug in to make this statement be true. This inequality. Problem 52 reads, pentagons have 5 diagonals as illustrated below. How many diagonals does a heptagon 7 sides below have? Well, there's a formula for the number of diagonals in a polygon. And the formula reads n times n minus 3, everything divided by 2, where n is equal to the number of sides of the polygon. So if you know this formula, you're good to go. The pentagon has 5 sides, so n is equal to 5. So if you plug that in here to find the number of diagonals in a pentagon, it would read 5 times 5 minus 3, and then everything divided by 2, so that gives you 5 times 2, and everything divided by 2, 10 halves, which is 5. 5 diagonals. It checks out, and you can see them here. 1, 2, 3, 4, and 5. Now for the heptagon, where n is equal to 7, because it has 1, 2, 3, 4, 5, 6, 7 sides, it would read, if we plug in here, it would read 7 times 7 minus 3, everything divided by 2. So that would be equal to 7 times 4, everything divided by 2. 7 times 4 is 28, so 28 halves, which is equal to 14. 14 diagonals, which is choice H. Now, if you don't know the formula, what you would need to do is, and let's use some coloring here, start with, say, this vertex right here. So let's do all diagonals from that point. 1, 2, 3, 4. So we have 4 so far. then we could change the color here. So let's do from this point now. 6, 5, 6, 7, 8. I'm sorry about that. So it's plus 4. Now let's change the color again. That would be from, say, this point right here. We already have that first line going up there. So we do the other ones. 1, 2, 3 more. Plus 3. Then let's change the color again to this one. For this vertex right here, I already have 1 and 2. So I just have 3 and 4. These two additional missing. So plus 2. And then finally, we have this diagonal left, which is from this point right here. We already have 1, 2, and 3. So it would be this one right here, the remaining plus 1. So if we add all of these together, we end up with 4 plus 4 is 8, plus 3 is 11, plus 2 is 13, and plus 1 is 14. The same number. So you didn't have to know the formula. It helps because then you quickly find it. But if you don't remember the formula, you could have still drawn the